Okay, class. So I received a few questions earlier this week on how to calculate the solubility of a salt. And so these questions came from number 8 and number 9 in the homework. So if you still need help with calculating solubility or determining solubility of a salt, this is what this video is for. So for question 8, it asks, which of the following salts would have the greatest solubility? So there are two things that we look at when determining solubility. Of course, the KSP, right? Because the KSP is equal to the concentration of your ions formed. But we also look at the number of ions that are produced. And so the number of ions produced is going to affect the solubility as well. For this first question, though, we have 4 salts, right? And each of these salts produces the same number of ions. So we have barium fluoride. Barium fluoride produces one barium ion and 2 fluoride ions. So you have a total of 3 ions. Lead fluoride produces 1 lead ion and 2 fluoride ions. Again, 3. Strontium fluoride and calcium fluoride both produce 3 ions. So if the salts that you're comparing all produce the same number of ions, then we simply look at the KSP value to determine its solubility. So in number 8, we go with the highest KSP. Because remember, the highest KSP means it's in favor of forming product. And in terms of solubility, product means which one forms the ions. Which of these salts is ready to go into ion form, right? So the higher the KSP, the higher the solubility. Now question 2 or question 9 on the homework was a little bit trickier, but it's only because in this case, we were looking at salts that did not produce the same number of ions. And when your salts do not produce the same number of ions, you have to do a modification of the ice table. So silver chloride, right, breaks into 2 ions, right? Silver and chloride ion. The lanthanum fluoride ion breaks into 1 lanthanum ion and 3 fluoride ions. So you have a total of 4 ions produced. Copper bromide breaks into copper and bromide ions, 2. And then calcium fluoride. Calcium fluoride breaks into 1 calcium and 2 fluoride ions. So we have 3 ions formed. So we cannot simply look at the KSP value of these salts when trying to determine which one is more soluble, because they produce different amounts of ions. And so the number of ions formed affects the solubility. So the only way we can figure out the solubility of these salts, or which one is more soluble, is to do the modification of our ice table. So I'm going to show you how to do that really quick. All right, so let's look at number 1. So the first one, silver chloride. We know that KSP is equal to 10 times negative 10. And we also know that the KSP is equal to the concentration of our products. So it's going to be X times X. Right? This first X is for silver. This second one is for the chloride ion. So that simplifies to X squared. So to determine the solubility, in X in terms of solubility, it's kind of like, we call it molar solubility. So it's kind of like the concentration. So the units are in molarity, right? But instead of calling it the concentration of our ions, we're looking for the solubility of our ions. So when we solve for X, we help to determine its solubility. So to get the solubility of silver chloride, we have to take the square root of 1.8 times 10 to the negative 10. And you should have gotten 1.3 times 10 to the negative 5. All right? I'm going to show you how to do the second one. And I'll come back and rewrite all of those answers for you. So now we have lanthanum fluoride. So lanthanum fluoride, our KSP, is equal to X, right, which comes from lanthanum, times 3x cubed. And so we have to include that 3 here, right? Because we produce, for every 1 lanthanum ion that is produced, you produce 3 fluoride ions. So we have to have that 3 there as the coefficient. But we also have to include that coefficient in our exponent, right? And so our KSP is equal to x times 3x cubed. Now to simplify this, we do KSP is equal to, we cube the 3, so that's going to be 27. And then we multiply the x's. So we have x cubed times x. So it's going to be 24x to the 4. So KSP, our solubility, is equal to 24x to the 4. Now putting in this in the calculator is a little tricky, but I YouTubed it and I found a video, and I'll try to remember to put, to give you the link. But basically, you're going to need one of these two buttons on your calculator. So you should have a button on your calculator that looks like this, right? So it's an x and the square root, or an x to the y. If you have the one with the x to the y, you're going to be using the inverse of that. I have the one with the x and the square root button. And so I'm going to tell you how I put this in my calculator. So first I did my KSP. We know that the KSP is 2 times 10 to the negative 19. That's equal to 27x to the 4th. The easiest thing to get rid of is the 27. Divide both sides by 27. Alright, so I'm going to show you how I did that really quick. I keep saying really quick. Alright. So 2 times 10 to the negative 19 divided by 27, because remember we need to get rid of that 27, is equal to x to the 4th. Now, if you're like me, I rarely use this on my calculator, so I had to figure it out. So what I did was, you put 4 first in your calculator, put the number 4, then you hit that button that looks like this if you have a calculator like mine. And then in parentheses you do 2 times 10 to the negative 19 divided by 27. Make sure it's in parentheses, close parentheses. And your answer should be 9.3 times 10 to the negative 6, if you did it correctly. The other thing you could do is, if you don't have this x to the, with the square root on it, do the inverse of x to the y and put that in this place. But I'll send you a link if you can't get that to work. But hopefully most of you can get that to work. Alright, so for the third one, copper bromide, how do we set this up? Well, we know that KSP is equal to x times x. Again, simple because we're only producing 1 ion of each. So the KSP for copper bromide is equal to x squared. So all we have to do here is take the square root of 5.3 times 10 to the negative 9. And you should have gotten 7.3 times 10 to the negative 5th if you did that correctly. Last one. So KSP is equal to x, right, 1 calcium times 2 fluorides. So for every 1 calcium produced, we make 2 fluorides. So we have to do 2x, and whatever that coefficient is, we have to raise it. So this now simplifies when you do 2 squared to 4x cubed, because we're going to multiply x times x squared, which is going to give us x cubed, and then do 2 squared, which is going to give us the 4. So KSP for calcium fluoride is equal to 4x cubed. So how do we put that in our calculator? We take our KSP, which is 3.5 times 10 to the negative 11. We know that that is equal to 4x cubed. The easiest thing to get rid of is the 4. So divide both sides by 4. So now your answer is equal to x cubed. So how do I put this in my calculator? So again, put 3 first. Whatever that exponent is goes first. Then you hit this button, or the inverse of the x to the y button if you have that. And then in parentheses, you have to do 3.5 times 10 to the negative 11 divided by 4, close parentheses. And your answer for the fourth salt should be 2.1 times 10 to the negative 4. So I hope this helped, but let me rewrite all 4 answers, and then you can help me to determine which one is the most soluble. Alright, so our solubility for silver chloride was 1.3 times 10 to the negative 5. For lanthanum fluoride, we got 9.3 times 10 to the negative 6. For copper bromide, we got 7.3 times 10 to the negative 5. And then for calcium fluoride, we got 2.1 times 10 to the negative 4. So which of these 4 salts would be the most soluble? The one with the largest KSP value, which is 2.1 times 10 to the negative 4.